Our names are Arianna, Sidney, and Caroline, and we're researching London's Thames Barrier in the hopes of finding out whether or not the barrier will remain a viable method of flood prevention in the coming years, in lieu of rising sea levels and climate change. The footage used in this video is from our personal trip to the barrier, located between the London boroughs of Newham and Woolwich on Eastmoor Street.
Before we answer our big question, let's first discuss the basics, which is sea level rise. Around the world, cities are seeing an increase in sea level rise, resulting in more frequent flooding, leading to mass destruction and even tragedy. But what exactly causes it? Well, the two major causes of global sea level rise are thermal expansion caused by warming of the ocean, since water expands as it warms, and increased melting of land-based ice such as glaciers and ice sheets. A study from the NOAA on global sea level rise states that ice loss from the Greenland ice sheet increased sevenfold, from 34 billion tons per year between 1992 to 2001 to 247 billion tons per year between 2012 and 2016. In addition, the study also stated that Antarctic ice loss nearly quadrupled, from 51 billion tons per year between 1992 and 2001 to 199 billion tons per year from 2012 to 2016. As a result, the amount of sea level rise due to melting from 2005 to 2013 was nearly twice the amount of sea level rise due to thermal expansion. Higher sea levels means that deadly and destructive storm surges push farther inland than they once did, which also means more frequent nuanced flooding. But how can we measure sea level to track the flooding? Well, sea level is measured by two main methods: tide gauges and satellite altimeters. Tide gauge stations from around the world have measured the daily high and low tides for more than a century using a variety of manual and automatic sensors. Using data from scores of stations around the world, scientists can calculate a global average and adjust it for seasonal differences. The State of the UK Climate Report 2020 shows that UK sea level rose by over 16.5 centimeters or 6.5 inches since 1901. These sea level rises are affecting London's Thames River. But what measures are being taken to help prevent this flooding? Here's where the Thames River Barrier comes into play.
The history of the Thames Barrier. After the London floods of 1953, which killed 307 people, citizens of London and the London government began to take matters of flood prevention far more seriously. In the years up until 1970, general flood solutions were raising seawalls higher and higher and creating more embankments, but greater prevention became necessary due to rising sea levels and the need to preserve views of the Thames. The model concept of the barrier and rising gates was thought of in 1969 by architect Reginald Charles Draper, based on the taps of his gas cooker at home. It was then further designed by architectural firm Rendell, Palmer and Tritton for the Greater London Council. The Thames Barrier Act was established in 1972, and official construction of the barrier became certified. Construction on the barrier began in 1974 and was completed officially in 1982. Work began in two sections. Firstly, the southern piers were built, and then the northern piers were added. The barrier cost £461 million to build, with an additional £100 million for river defences. It was officially opened by Queen Elizabeth II on May 8, 1984. How the barrier was installed. The Thames Barrier was built over the 520-metre stretch of London's Thames River and protects 125 square kilometres of London from flooding produced by tidal surges. The barrier divides the river into four sections, each 61 metres across. It has 10 steel gates that can be raised into position across the River Thames. The floodgates are circular segments that move into their raised position by rotating. Each gate is hollow and fill with water as they sink and empty as they emerge from the river. Each one is 20.1 meters high and weighs 3,700 tons. The Thames Barrier is today one of the largest movable flood barriers in the world. The barrier is maintained by the Environment Agency of London, which maintains other flood defences of London as well. The barrier undergoes monthly maintenance and testing to ensure its proper functioning.
The Thames Barrier consists of 10 steel gates that can be raised into position across the River Thames. When raised, these gates are as tall as a 5-story building and as wide as Tower Bridge's opening. The Environment Agency/Meteorological Office Flood Forecasting Center can predict dangerous weather conditions up to 36 hours in advance. This information is then given to the barrier controllers, whose responsibility it is to decide whether the barrier needs to close. The barrier will then remain closed over high water until the water level downstream of the Thames has reduced to the same level as upstream. It takes about 5 hours to complete this process, but the potential consequences of closing the barrier extend beyond a potential waste of time or money. According to the Environment Agency, the risk of the barrier failing is increased the more it is closed, as frequent closures will affect the maintenance regime and damage the equipment. While the Thames Barrier is a strong defense system, it requires regular maintenance in order to keep it working efficiently. In a 2010 report from the Environment Agency, 50 was reported as the maximum number of times the barrier should close each year to, quote, reduce the chance of it failing to unacceptable levels. The report goes on to say that the estimated design limit of 50 closures per year will be exceeded from 2135 onwards. While the failure of the Thames Barrier does not appear to be an immediate threat, the impact of climate change on the Thames can already be seen. Sea level rise in the estuary has accelerated over the last few decades. Between 1911 and 2018, sea level rose on average by about 1.4 millimeters relative to land, versus 3.6 millimeters per year between 1990 and 2018. As sea levels continue to rise, the height of storm tides will increase and the barrier will be rendered less efficient. The Environment Agency does recognize and acknowledge that the barrier will need to be upgraded or replaced entirely with a higher barrier further downstream, but they provide no further details. While it is clear that the Environment Agency's 2100 plan is aware of the threat climate change poses to the integrity of the barrier, the aim of our research is to decide whether the EA is doing enough to prepare London for future flood risks.